Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede, and it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide or simply DMS in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, It's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini-Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations. 2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is, and that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these 2 Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these 2 new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with 2 instruments, espresso and Carminis. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun. Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the Swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. Bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100-gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri b. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star, which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri b. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri b isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri b makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star where the temperatures on the planet should be okay-ish and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height, because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.